Dear students, welcome to the classes of Optical Fiber Communication in the 7th semester, Electronics and Communication Engineering. We already know the communications medium in most electronic communication systems is either a wire, conductor cable or free space. But now a new medium is growing in popularity, that is called a fiber optic cable. We already heard about the fiber optic cable that is in our telephone system, the cable TV system in our home, or the fiber to home, the internet system in our home. So what is fiber optic cable? A fiber optic cable is essentially a light pipe that is used to carry a light beam from one place to another. That is, a fiber optic cable is simply a light pipe. It just carry light from one place to another. Then the fiber optic lines are strands of optically pure glass as thin as human hair. That is, the fiber optic are made of pure glass. Sometimes it is made of plastic as thin as human hair, and it carry digital information over long distances. You just note it carry digital information over long distances. And they are also used in medical imaging, mechanical engineering applications, in a lot of applications. In this PPT just written two applications in medical imaging and mechanical applications, electronics, mechanical, all other applications it is used. So we already studied the optical fiber is essentially a waveguide for light. Waveguide means it's simply a guide light through the path. Then why we use light? There is a question arises, why we use light in this optical fiber communication. We know light is an electromagnetic signal like a radio wave, and it can be modulated by information signal and sent over the fiber optic cable. Then the structure of an optical fiber, it consists of a core and a cladding that surrounds the core. You just note it consists of the inner portion of the fiber optic is called core and outer portion is called cladding. I will show you the figure later. The index of refraction of the cladding is less than that of the core, causing rays of light leaving the core to be refracted back into the core. That is a main important point in the fiber optic communication. That is the index of refraction. Index of refraction means it is the speed of light in air to the speed of light in that medium. That means the amount of refraction is called the index of refraction. It is the ratio of the speed of light in air to the speed of light in another medium. That is, if we want to calculate the index of refraction in vacuum, the equation is the speed of light in air to the speed of light in that medium. So the speed of light in vacuum is 3 into 10 raised to 8 meter per second, and the speed of light in by C by V, that is already it is 3 into 10 meters, that is its answer is equal to 1. So in case of vacuum it is equal to 1, and in case of air it is 1.0003, and water is 1.33, and so on. And why we use this light as optical communication? That is, the frequency of light is extremely high, that we already know, and it can accommodate very wide bandwidths of information and extremely high data rates that can be achieved with excellent reliability. Also, an advantage is that it has wider bandwidth, low loss, lightweight, and small size, and etc. And it has many disadvantages that it is small size and brittleness make it is more difficulty to work with. Then what is the source we used as light? A light emitting diode, LED or laser diode, can be used as a source. The advantage is that greater bandwidth, low loss, immunity to crosstalk, no electrical hazard, etc. Then a John Tyndall demonstration 1870, that is, a light is passed through a beaker, then light is reflected from the source. This because of the incident angle is less than the critical angle, so the light is gradually leaks out. So this is a John Tyndall demonstration in 1870s. So total incident reflection is the basic idea of the fiber optics. So what are fiber optics? That is, we already studied, it's a long thin strands of very pure glass about the diameter of a human hair, and they are arranged in bundles called optical cables, and are used to transmit light signals over long distances. Then the refraction and total internal reflection. So if someone asks you what is the principle behind the light pass through your optical fiber cable, you just answer it as total internal reflection. The figure A, N1 is of a media and N2 is of another media. For example, N1 is of water and N2 is of air, or N1 is air and N2 is water, and separated by a medium. If light is passed from N1 to N2, theta 1 is the incident angle. In first condition, the angle of incidence is less than the critical angle. The light is refracted through it. That is the angle of incidence less than critical angle. First A figure is the refraction. Second figure B, the angle of incidence is equal to the critical angle. The light must pass between the interface between two media. That is the B figure. Then third figure is the principle of the optical fiber communication, that is total internal reflection. That is, the angle of incidence is greater than the critical angle. The light must be passed inside through it. That is, the light must be passed through the core. That is, the angle of incidence is greater than critical angle. It is the total internal reflection. Then next is the numerical aperture. The numerical aperture means the light gathering capacity of an optical fiber. That is, light gathering capacity means it is the amount of light that can acceptable by a fiber. And a simple equation, you don't confuse with the symbol, numerical aperture equal to root of n1 square minus n2 square. The numerical aperture of the fiber is closely related to the critical angle and is often used in the specification for optical fiber and that components that work with it. You just studied the definition. Numerical aperture is used to describe the light gathering or light collecting capacity of an optical fiber. And another equation, numerical aperture is equal to sine theta in, where the theta in is the acceptance angle, and equation numerical aperture is equal to root of n1 square minus n2 square. Here is the basic block diagram of an optical fiber communication, the basic block diagram. In this figure, the information, that is the voice or video, you just remember about the cable connection in our home, that is the voice and video we received. Coder or converter. Coder or converter means we just convert this voice or video to the digital form, that is zeros and one pulses. Then these zeros and one pulses just transmitted through the light, that the light source transmitter. The light source transmitter we used is laser or LED or laser diode. Then it passed through the fiber optic cable. Then photocellular light detector, there is a photodiode is placed above it. Then this light is amplified by an amplifier. Then in the receiver side again a shaper, that is we convert these into correct pulses, zeros and ones. Then we used a decoder, that is we decode these zeros and ones pulses into original voice or video. This is simple block diagram for an optical fiber communication. Then here is the structure for optical fiber, that is the white portion, at the end, the tip of the white portion is like the optical fiber. It is diameter just as like the human hair. Then the outer colored portion is the cladding portion. Then the outer jacket for protection. This is the figures of optical fiber. Then another figure, the optical fibers, the inner jacket, some designs. These all are the figures of an optical fiber. Then again the fiber core, that is the yellow like portion, the blue like portion is glass or plastic cladding, and the plastic jacket. In the right bottom figure, the red line is passed light through the core only, that is you must remember the light is passed only through the core. The yellow line is the light is sometimes the incident angle is less than the critical angle, the light is refracted towards the core, that is the yellow line. It is an error in the fiber optic communication. So again a figure, it is core and cladding, the buffer coating, just like the figure here. A figure showing the fiber optic is passed through underground. That is a simple figure to show. This is all about the introduction of the optical fiber communication. Thank you.